Okay, so you're welcome to class, everyone. It's good to have you here, and this is Teacher Olumide. Now, the question we are going to be solving, they are all based on indices, and in the topic of indices, there are some basic laws that guides it. So, I'm going to be taking each any question that comes with a particular law. I'm going to be taking the law so that it serves as a reminder. So, take for instance, the first law we are going to be applying in this question is that if you have a fraction and it contains a negative power, the law states that we can remove that negative power by saying this is the same as p over a, or raised to the power m. Another law is that if you have a raised to the power m over n, that's if you have a fractional power, the law states that you take your roots, your n, which is the denominator, comes here, and your m, which is your numerator, becomes the power. So having that at the back of our mind, if we are going to attempt the question that is above, so that means 27 over 125, the negative power that is there is going to go. So that means it's going to become 125 over 27 raised to power 1 over 3 times the 4 over 9 raised to power half. Now, if you look at what we have now, it follows from the second principle that anytime there is a fractional power, you can take the roots. So we have 125 over 27. But the denominator here is 3. So you can bring the 3 here. The numerator is 1. Put the 1 there, just for more understanding. Now, in this case now, this 2 that is here is indicative of the square root symbol. So you don't need to put the 2 here. So just write the square root symbol and write 4 over 9, all raised to power 1. And from here, it becomes easier because the cube root of 125 is 5. That's what number can you multiply 3 times? 125 is the same as 5 times 5 times 5. So that means the cube root of 125 is 5. Because if you multiply 5 in 3 places, you get 125. So all over, the cube root of 27 is going to be 3. Because if you multiply 3 times, you're going to get 27 times. Now here, the square root of 4 is 2. And the square root of 9 is 3. So from here, we have 5. Anything raised to power 1 is that thing. It doesn't change. It's 3 times 2 over 3. Then we have 10 over 9. Or we want a number. Or we can finalize by saying this is the same as 1 or number 1 over 9. So that's the solution. Okay, so we have the second question here. Now, put it at the back of your mind that all these questions we are taking, they are all Y standard questions. So we are just trying to test ourselves with some of the questions we've ever been given on indices. So if we're going to attempt this question now, this one is more of an equation because of the presence of the equals to. Now, in solving any indices, indicial equation, one of the things we need to have at the back of our mind is that if y raised to power a is equal to y raised to power b. Now the bases are the same. Base y is equal to base y. So it then follows that a is equal to b. So in solving any question on the indicial equation, what you will try to do is, can you make the bases the same? The moment you've achieved that, you can easily equate the powers. So a quick example is if you have 3 raised to power x equals to 9. This is base 3, base 9. So easily we can say 3 raised to power x equals to 9 is 3 raised to power 2. So you can see that you've made the bases the same. So you can easily say x equals 2 because the powers are also the same. Now, using that to solve this question, you'll find out that in this question, we have different kind of bases. We have base 16, base 2, base 4, base 8. Now, I want to work with uniformity. So I want to start changing everything to be in the same base. So for instance, 16 is 2 raised to power 4. By 2 raised to power 4, we mean 2 times 2 times 2 times 2. It's going to give us 16 times 2 raised to power x plus 1 equals to 4 is 2 raised to power 2. The x is there. Times 8 is 2 raised to power 3. 1 minus x. And from here, we can have that 2 raised to power 4 times 2 raised to power x plus 1 is equals to 2 raised to power, we have 2x times 2 raised to power 3 multiplying 1 is 3 minus 3 multiplying minus x is minus 3x. So from here now, we can apply the law of indices that if you have a raised to power n times a raised to power n, anytime you are multiplying two indices and they have the same base, the law says that you can add the powers. So from here, we have 2 raised to power 4 plus x plus 1 is equal to 2 raised to power 2x plus 3 minus 3x. That's adding these two powers here and adding these two powers here as well. So from here now, you can see that 2 raised to power 4 plus x plus 1. So 4 added to 1 is going to give us 5. So that's 2 raised to power 5 plus x. Nothing is going to be added to the x. So this 4 plus this 1 is what gave us 5. 2 raised to power. So we have 2x minus 3x here. That's going to give us minus x plus 3. You can see that we've been able to achieve that these two bases are equal. So you can immediately say 5 plus x equals minus x plus 3. And from here, we can just collect like terms x. If we take the minus x to the other side, it becomes plus x equals to 3. If the 5 should go to the other side, it becomes minus 5. So we have 2x equals to minus 2 and x equals to minus 2 divided by 2. And finally, x is equal to minus 1. So that's how we attempt that question. We go to the next one. All right, so the next question says we should simplify 0.064 raised to power negative 1 over 3. So now, the first issue we have here is that what's in the brackets is in decimal. And you know every decimal number can easily be converted into a fraction. So from here now, 0.064. So this decimal point, you take it 1, 2, 3. That means 0.064 is the same as 64 over 1000. This 3 times we have moved towards the right is indicative of these 3 zeros. So we can now change the question back and say that 0.064 raised to power minus 1 over 3 is now 64 over 1000 raised to power minus 1 over 3. The moment we do this, this gives us another problem. Like we stated earlier, that if you have a negative power, it will interchange the fraction. So it becomes 1000 over 64 raised to power 1 over 3. Okay, so from here now, we have that this is the same as cube root. Don't forget the denominator, which is 3, comes to the root side. 1000 over 64, all raised to the power of 1. Now, what number are we going to multiply 3 times? That's the meaning of cube root to get 1000. That's 10. What number are we going to multiply 3 times to get 64? That's 4 raised to power 1. So 2 can go in this. 2 in 10 is 5. 2 here is 2. So we have 5 over 2 raised to power 1, which gives us 5 over 2. So that's the answer. All right, so the next question asks us to simplify this easily. Dealing with 8 raised to power 2 over 3, you know that this is equals to cube root of 8 raised to power 2. From the fact that this denominator comes to the root side, then these two remain times. This one now, there is a law that says if you have a raised to power minus m, it is equals to 1 over a raised to power m. So that means 27 raised to power minus 1 over 3 is going to become 1 over 27 raised to power 1 over 3, all divided by 64. All right, so the cube root of 8 is 2, because if you multiply 2 3 times, you're going to get 8. So cube root of 8 is 2 raised to the power of 2 times 1 over. This means the cube root of 27 raised to power 1 all over 64. And from here now, we have 4 times 1 over. The cube root of 27 is 3, all divided by 64. Now, this is the same as 4 times 1 over 3 is the same as 4 over 3 divided by 64. And this is equal to 4 over 3 times 1 over 64. So 4 can go 4 here, 1 is 64. That will be 16. And that will be 1 all over 48. All right, so the next question, number 5, is we have 2 divided by, straight away applying the law, this negative sign is going to interchange the fraction. We have 125 over 64, and we are raised to over 3. And from here, we have 2 divided by, this is going to give us the cube root of 125 all over 64 in brackets, all raised to the power of 2. So we have 2 divided by, now the cube root of 125 is 5. So we have 5 over the cube root of 64 is 4, all raised to the power of 2. And from here we have 2 divided by 5 raised to the power 2 is 25 over 4 raised to the power 2 is 16. And this is going to give us 2 times 16 over 25. And from here, 2 times 16 is going to give us 32 over 25. And here is your answer. All right, so for this next question, it looks trickish, but we are going to be applying some wisdom to solve this question. So solution, we have that. So from here now, we have 6 raised to the power 2n plus 1. Now, we want to change each of these bases to something like, so this 6 now is the same as 6 raised to the power 2n times 6 raised to the power 1. If you remember from the law of indices, base 6, base 6. So it is the same as adding their powers. So if you pick one of the base and you add their powers, it still gives you the original question. So let's leave 9 raised to the power n. We'll see the reason later on. And this 4 raised to the power 2n, you can change it to 2 raised to the power 2. Then we have the 2n, all divided by 18. You can change 18 to 9 times 2 raised to the power n times 2 raised to the power n times, we can change 12 to 6 times 2 all raised to the power 2n. Now from here, we know that a times b raised to power n is the same as a raised to power n times b raised to power n. So it's the same as you giving each of these content of this bracket. The a takes the power of n, the b takes the power of n as well. So using that principle here, we have 6 raised to power 2n times 6 raised to power 1 is 6 times 9 raised to power n times 2 raised to power 4n, multiplying these two all over. This one, now splitting it, we have 9 raised to power n times 2 raised to power n times 2 raised to power n times 6 raised to power 2n times 2 raised to power 2n. So from here, you can see that this cancels this cancels this. So what else do we have? We have 6 times 2 raised to power 4n all over. Now combining these two together is going to give us 2 raised to power n plus n times 2 raised to power 2n. And this is going to give us 6 times 2 raised to power 4n all over 2 raised to power 2n times 2 raised to power 2n. And this is going to give us 6 times 2 raised to power 4n all over 2 raised to power 2n. You pick 2, then you add the powers 2n plus 2n. And from here, it becomes much easier. You have 6 times 2 raised to power 4n over 2 raised to power 4n. This cancels this again. And finally, we have an answer of 6. Alright, so for the next question, we've been asked to simplify this. This should be pretty much easy for us. This minus that is for the power is going to make this fraction to interchange. So we have 16 over 81 or raised to power 1 over 4. And what we want to do now is this 4 now, we can take it here. Then we have the 16 over 81 or raised to power of 1. Now the fourth root of 16, what this indicates is fourth roots. That means what number can you multiply 4 times to get 16? So 16 is equals to 2 times 2 times 2 times 2. And 81 as well. The cube root, the fourth root, if you have 3 times 3 times 3 times 3, that's going to give you 81. So that means the fourth root of 16 is 2. The fourth root of 81 is 3. 1 raised to the power of 1. 2 raised to the power 1 is 2. 3 raised to the power 1. So 3. Easy peasy. Alright, so the last question we are going to be solving is what we have here. So we have 10 raised to power minus 3x. If you remember from the law, I said y raised to power a equals y raised to power b indicates that a equals to b. Since this base y are equal, you can say a is also equals to b. But if you look at this right hand side, we have a fraction. So we can first of all turn this 1000 to 10 raised to the power of 3. 10 in 3 places is going to give us 1000. So from here, we have 10 raised to power minus 3x equals to. Now, if we have 1 over a raised to power m, this is also equals to a raised to power minus m. That means this 1 over a raised to power m, by the time it goes up, it becomes this. That means 1 over 10 raised to power 3 is also the same as 10 raised to power minus 3. Base 10, base 10. We can say minus 3x equals minus 3. So we divide both sides by minus 3. And we have minus 3 over minus 3. So that means that x is equals to 1. Thank you so much for joining up in the class, and thank you for attempting the question. God bless you all.